Kia ora Year 12 and Year 11. I'm going to video a couple of questions from Assignment 5. So I've just about finished marking it and you guys have done really well, but there's one question in here that is quite tough. So I thought, as well as you having the work solutions, I want to talk through two different ways to solve this problem here, which is a pair of simultaneous equations with complex coefficients. And then I'm going to go very slowly through 11b. So 11b is one of those questions where a really good diagram is going to help, and linking up some ideas from vectors last year is also going to help. So I've just noted there that this one here really is tough at this stage in the year, so please don't beat yourselves up for not getting it quite yet. Right, let's look first at these two simultaneous equations. We've got two complex numbers z and w, and they satisfy two equations, here and here. And we need to solve them for z and w. So let's start by writing them down and then taking a look at what we can do. We've got that one, and then we've got this one. Now I think all of the assignments that I've marked so far had you guys go, oh, we can do substitution, and that works fine. So let's start by saying, what is z? Well, z is I minus 1 plus I times w. And we're going to take this, we're going to chuck it in here. It's going to get a little bit messy, but then we're going to solve for w. Then we're going to substitute back in to get z, right? Just like you did back in Year 10. I want to go through some little shortcuts that I've done on the working. So most of you got this one, but some of you did a couple of wee things. One person wrote it out wrong with a plus, so always check what equation you're meant to be doing. So let's substitute in. We've got 1 minus I times this. So we can see we're down to one variable, we've got no more z. But when I expand this, I'm going to do it a little bit smartly. I'm going to do this times I first, so we get I minus I squared. And then I'm going to do this. I'm going to go 1 minus I times 1 plus I w. Right? So I'm not going to go through to start with and expand all of that out. It just speeds things up a bit. And it's come up already in scholarship that sometimes partially expanding can be a good, efficient step in the process. So let's clean this up now. We've got I minus I squared, so plus 1, minus, now this is a difference of two squares with complex numbers, so we have 1 plus 1, which is just 2. So that's why I spotted that and didn't expand it out further. So it speeds that up a bit. So we have I plus 1 minus 2w plus iw is equal to 1, giving me I plus iw minus 2w is equal to 0, taking 1 off both sides. So finally we can solve that for w. We get w into negative 2 plus I is equal to negative I, and w is equal to negative I over negative 2 plus I. Now you can leave it like that and do your conjugate multiplication there, or you can times everything through by negative 1 over 1. The reason I like to do that is because I'm better at multiplying when the first number is not negative. Right, so here, what have we got now? Well, we'll times top and bottom by the conjugate of 2 minus I, giving me 2I plus I squared over 4 plus 1, which equals 2I minus 1 all over 5, and w is equal to negative 1/5 plus 2/5 of I. Okay, so we've got that, and now we're doing substitution, so we chuck that back into my equation for z. I want to show you another wee shortcut here for doing that. So z is going to equal I minus 1 plus I times w, which is this. And I find it much easier to expand that as follows. Take out the factor of 1/5, either at the start or the end, and just write it like that, because my brain works better on that than it does on all of that. So we've got I minus 1/5 negative 1 minus I plus 2I plus 2I squared, which is I minus 1/5 of negative 1 minus 2, so negative 3 plus I. It's a really fiddly question, this one, so you don't want to get the whole way through here and make some stupid little mistake because of that expansion. So finally we've got down to z is equal to 3/5 plus 4/5 I. So that's done. But what I want to do now is show you how we can do this question using elimination, because I think it's slightly easier and it's a good method to have in your algebra toolkit. So when we do elimination, we used to do it with questions like this: 3x plus 2y equals 17, x minus, 4x minus 6y equals 8. And then we try to match up coefficients. And it's going to go the same way here. I'm going to take my two equations from that question, and I'm going to write them in order. So I have z here, so z in this column, w in this column, and then equals the constant part over here. So what do I get? Well, I've got z plus 1 plus I w is equal to I, and then 1 minus I z plus IW is equal to 1. So if we look at that, what I'm trying to do is to match coefficients. Now I've got I here and 1 plus I here. There's no obvious easy multiplication there to go between one and the other, so forget about that. Instead, let's focus here. I've got 1 minus IZ here, and I've got nothing Z here. So if I times everything through in this one by 1 minus I, that's going to be a good first step to make. Right, so we call this equation 1 and this equation 2. So if we multiply through equation 1 by 1 plus I, this is what I'm going to write out. And then underneath it, nothing changes. Now we're going to subtract. I'm going to call this 1 dash, and this is 2. So I'm going to do equation 1 dash minus equation 2, and this is all gone, this bit here. So we're left with this 1. What have I got here? 1 plus 1, so 2w minus iw is equal to I minus I squared minus 1. So I don't know about you, but I reckon that's easier than doing substitution. So we've got w into 2 minus I is equal to I plus 1 minus 1. So w is equal to I over 2 minus I. And then I can go on as I did before, right? So I'm not going to finish the rest of it off again because we're back to exactly the same point. Right, now I think 8 minutes on this video is probably long enough because it's going to take me more than 10 minutes to do the hard question. So that's all for this video. I will go through the big diagram one in another few minutes. Thanks for watching.